You mentioned something about data yesterday also, data store or data set.
Okay. All right. Thank you. Any other person? Any other try?
Good afternoon, sir.
Yeah, good
Yesterday,
afternoon.
the recap of yesterday was that we created a machine learning using Azure. We talked on computing instance. We did something about data sets from data files, and no, it's there's a way machine learning is related to data sets, linking link services and all. Yesterday, I think that was what we did yesterday.
Okay. All right. So if you guys remember, we added data from a specific URL to to our work environment. Sorry, I started recording. I don't know what happened yesterday. The call was very long, so I need to as much as possible make it interesting, precise, and get to what exactly we want to do. Okay, so permit me to share my screen, and please let me know when you can see my screen. I do hope that you all can hear me.
Yes, sir. We can see your screen and we can hear you.
Yes.
Sorry. So the code space is not available right now. Tried checking the repos, but cannot access it. So we're looking at other examples that we could use to do that. Code space, code space. So right now, we can't actually use code space now. So we would continue with our other labs, but I'll do basically how the work is, how to use code space here. So, our kernel actually would have been turned off by now. This was the code we ran yesterday from different, from this that we have here. Then the next one we would be looking at is maybe coming here, and we also look at training our models. Be looking at training our models, or running experiment, training models, working with data stores, working with data sets, and then different stuffs that we would be introduced to. So it's going to be a long lab. And I will encourage each and every one of us to find a solution around how to have an Azure, a free Azure code space, Azure ML Studio and then get a free Azure subscription for yourself. Sorry, I need to change my environment. There's so much noise here. Please be patient. Yes. I'm here. Sorry, guys. Do hope. Yeah. Okay. So, sorry. So I find it cool. I found something cool. For those of you who are probably getting introduced to computer science and all that want to practice, or you want to learn how to code from the very beginning, or having insight, or having a platform that will help you to think as a developer, even when you are a data scientist, because you are still writing code, developing algorithms. It would be great if you have a work area or a platform where you can learn. So you can go to brilliant.org and you'll be able to access great learning materials. Really interesting way of learning and to help build you up. So once in a while when I come across this kind of materials, I like to share with you guys so that you can also use them in your free time or free period to develop yourself. Right, so back to where we were.
But it's not free.
It is free. It is free. You don't have to pay.
Brilliant.
You guys are always, yeah? You said? What did you say?
Like the brilliant, like that. I know it's not free, but I will check. It's a different one.
Thank you. I guess you try to use the premium.
Maybe.
You can see at the top here, it's asking me to try premium free for 7 days, and the offer has ended. I am not interested, and I'm not doing trial. So I'm just learning basically what is really available to use. Okay, so I suggest you guys should try it out. Just create your account and start learning. View the courses available, and you start learning. So let's go back here. How much do we have left? Is this today? Yeah, I still have 147. So you see, guys, you see how much we've been able to save. I think it was exactly 147 about yesterday, but with some cents here. We only used few cents yesterday, and this is the advantage of me stopping this guy and also deleting the compute. So let's go back to create our compute. We created a dedicated compute with CPU, then we did standard underscore DS2 v2, just so we are sure. The labs doc. Thing in there. So these are the configuration. DSV2 0, minimum of 0 nodes and maximum of 2 nodes. Maximum 2 nodes. Then how to turn it off? It should be idle. If it's idle before this, it should turn off. So it does automatic turn off itself. But I actually felt that the safest is for me to actually turn it off. So we need 2 of this and idle time for 120 seconds, 2 minutes, and then the compute we said is skills lab, cluster. Okay. Is it too long? It's too long. Okay, let's manage that. So we create a bag and we are good. I think someone is in the lobby. Okay. Yep. So Ibrahim is with us today. So I'm going back to, I think we are here. So brief explanation of the things before. So here, use, I've talked about how to use the Azure ML SDK in a compute cluster. And we were able to come to this place. We came here, so refresh. Oh, sorry. So it may not show it here. So this is how you access this, that Jupyter node, or it won't be able to. So I need to start running our compute instance. Sorry, start. So for you to come to this place, if you can remember, once this compute is running, you can then click on Jupyter. And we went to the terminal to install the SDK, Azure ML SDK, which is a key focus, how to use this Azure ML SDK in a compute instance. And this is your compute instance, which is what we are starting now. And I told us the difference between your compute cluster and your inference cluster. I said this one is for training, and then this one is for production. Okay, where you put your REST endpoint. If you've heard of REST, a RESTful state endpoint where you can send requests to, and then it does the prediction and sends you a response. So compute is still starting. We are waiting for it to start. And once it is started, we come here, we click on Jupyter, it opens the Jupyter notebook, and then we are able to run. We've already installed, if it's a fresh one, if it's a new computer instance, we have to do the installation we did yesterday. But since this is the previous one we did, we only stopped it. And now we are running it. So the packages we have installed, which is the Azure ML SDK, would still be there. And this is how you do it. You either upgrade it or install. Then again, we cloned this Git Clone, GitHub, which is, okay, sorry. You see it once this has started. Yeah, so it's taking a long time to start. So let me take us down to this. The same thing we did here, but this time around, we're using Jupyter Notes. Now, another way you could have this kind of environment, and it will look like this on your Visual Studio Code. And that's the web version. The web version of Visual Studio Code is what we refer to as code space. So code space, more like you don't have a laptop, but you have a system somewhere that you can use. Although the system does not have all the installations you have on your laptop, you can quickly log into that system, go to code space, and start up an instance of code space. So you have an environment like this on your Visual Studio Code. But this time around, a web version of the Visual Studio Code. That's what you're using. Okay. Right. Okay, so the process of doing that is to, like I said, you come here, but this is down. This is not running. It is pointing to GitHub right now, but it's actually configured to connect. When I did this training some time ago, I can't remember when now, on typing in this URL, it will take you to a code space to visualstudio.com, online.visualstudio.com, and you'd be able to create code space. So you create a code space, giving it your name, selecting a plan, and then you give it all this setup. You also link it to a GitHub repo that you already have. So you would have to clone this repo. I told some of you to clone it to your own, just like I have mine, Daniel DP-100 here. You have to clone to yours and then be able to use it on your Visual Studio Code. And also, just like the other things, so one of the things Microsoft tries to do is to do auto scaling, auto switch, auto stop, auto start on services it renders, such that it cuts down how much you would have to pay at the end of the day, just in case you forget to switch it off. So there are some, just like VMs, that you would have to turn off yourself. There are some VMs you have to turn off yourself. Then there are some that, if left idle, because the expense is high, it's costly because it's costly. If left idle for some minutes or for an hour or 2 hours, it should turn itself off. So depending on when you log in again, it will restart itself or starts itself. So Microsoft tries to include that in all services it renders. And so in this case, in your Visual Studio code space, it tries to give you to check for your idle period. And if it's up to 1 hour, to say you forgot to switch it off and you left for your home, it does that. So then once you do all these settings, you create the Visual Studio Code workspace, and then you just like your normal Visual Studio Code. Sorry. It looks exactly like this. It looks exactly like this. So you would have to learn how to create this when the service is open. So just like you did for Jupyter, you would have to install or go to the terminal and install the Azure ML SDK, just like you did for Jupyter under the Jupyter notebook here. You'd have to do the same for the Visual Studio Code because this is another environment, and then you would have to install that. Okay, so another way to use it the Azure ML SDK in the Visual Studio Code space, you would have to go to your Azure portal, which is here, and then you go to this, you come here to download this config.json. Data science lab. So you would have to download this. It's a JSON file. Then you would have to bring it to that environment, to the code space environment, and drop it in the notebook files there. It will probably appear at the end. If you have a list of files around here, it will appear at the end. So here you can see I have a file here and here. Then maybe like the third one is that you would, so in this case, this is what I'm saying. So just like this, it adds it here. So this is exactly the detail you have here. And you'd be able to connect. Remember, you needed this somewhere when we're doing the one with the Jupyter notebook. So I'll show you here. So when you loaded this workspace, every detail it has came with it. There was another place we accessed this. Okay, we're back. So it started now. Some of the things I was unable to show you for those who were not here yesterday. So the users, and you say DP-100. So you are seeing this here because we did it yesterday, and exactly how to do it was what I explained. As yesterday we came here, we were here, and then we came to new, we clicked on terminal, and the terminal opened. Sorry, still loading. And the terminal opened, and we pasted this code here. We pasted this code here. It did the installation for us. Hit enter, it does that. So I'm just basically showing us what we did yesterday, and then what is expected of you to do. So it's run this successfully. So you just check for upgrade, skipping upgrade because it already exists. So it didn't do any new download or any new installation. Okay. So the next thing is for you to do, go to users, under users. Basically cd users, then you inside the users folder, then you now do a git clone. But I'm not going to run that because I already have it. So this next command is what you're supposed to run here. But anyways, there's no harm in trying. Let's run it, even though we already have it. See, it's already telling you DP-100 already exists and is not an empty directory. So there's no need. It would have run or pulled this. It would have cloned what we have here from here. It would have cloned it to this repo. So you would have to do that. So it's cloning it from Microsoft Learn on a repository. Okay, so various stuff, and then I show us how to run this first one. Let me close this. You can close your terminal now because you're done with it. And then I said, you come here. These are the lab docs. The same files I've been opening on the other, on this place here, this same file, this lab 01MD is the same file you are seeing here. So there's nothing to worry about, but these are your code aspects. So when you open this, see your code here. So your kernel is already running, it's starting the kernel, and it's asking you to wait. You have to wait until the kernel is ready before you can run any code, okay? Some of you are familiar with this already. So the kernel is ready and trusted, you can run code, you can do run also, or if you can basically just do a shift enter, you would use it to run. So does this, shows you everything. So these are the things. Our compute targets, our skills lab instance, and the skills lab cluster. And we have only one data set, the one we added yesterday. I also show us how to add data sets. And so because of time, I might not be able to rush us again or take us through the step on how to create or add data set again, but it's really easy to do. All you just need to do is to come to home. You click on this drop down and click on data sets. It takes you there. So in this case, it takes you to the place you see the data set we have because we already have one. So you can use this, create data set, the drop down, and click on from web files, So when we selected from web files yesterday, we imputed the URL. The URL is found, so this is B. The URL is there on this lab 01A, the first part of the first lab. Yeah. So you see the URL. This is the URL to paste into this slot here. You give it the name. So everything you need to type here is already specified here. Anything you need to set is already specified here. So you just follow this setting and then you pull in the data. And it's as easy as that. So we don't need this, so I'm going to close that. This is the one we brought here. And that is why it is showing you here that the data set is this. So meaning that your Jupyter notebook is connected. This environment where you can do your machine learning, write your machine learning code, is already connected to your data. So a lot of you are used to getting data from Excel files or from TSV or CSV files. But in this case, you are connecting to a data in a web URL. Or you can connect to data in any place, in Azure, SQL Server, so you create a linked service and you connect to even your on-prem database. Okay, so I think that is that. We've shown enough. Let's go to what we have today. Hope I didn't miss anything out in this first lab here. So we've shown us this and then using how to use the Visual Studio Code machine learning extension. If you're familiar with Visual Studio Code, you know that if you want to write Python, you have to install the Python extension, whichever one you need. You need to be able to install it. So you do a pip install, whichever package you want. So that would be all that you are needed. Or you can go to the marketplace and search for extensions. You can see C# here. I've already installed C# on mine because I write that a lot. I installed YAML. For those of you who want to do infrastructure as code, you want to learn YAML. I did actually YAML for an Azure pipeline. So different things you can explore and search for whichever one you want. Maybe you want Python installed. Search for Python. Try to install Python for VS Code. Whichever one, you can do that. So you see the number of people who have installed this package, and it has successfully installed for me. All right. So meaning you can start writing Python code and it will execute. What you are trying to do is to add Python compiler. Add Python compiler to be able to run your code. So then from here, in your Visual Studio interface, you can click extensions and then you can search for this. When you search for this, you install it. So let's do this. Let's see if we can have it here. Let's see if we have it here. So it is here. Then you can install it. But I'm doing this on-prem. This is my local Visual Studio Code. Okay, so it's different from yours. So it's trying to install the Visual Studio Code. Then and see if you can connect to it. So after it is done, you can click on reload to load the environment with that. Load the environment you set up. That environment you set up here. Remember you did that here under your compute. You have this. This is your environment. This is another environment. So you have to bring in your cluster to that environment, and before it can be able to connect to it, get data, and be able to run or process stuff. So once you expand your compute clusters, you also verify your Azure Machine Learning cluster the compute, the one I just showed us now. So you can ensure that it is appearing in this workspace, and then you'll be able to use your code space. Once you close if you are using the workspace on the web, if you close the browser and it stays idle for 1 hour, it will automatically shut itself down. Okay. Any questions so far? Any question? No question. So every one of you, yeah? So, okay, all right, thank you. So welcome now, guys, to our lab 2. So we're going to take the first part of the lab, which is about creating a training pipeline with the Azure ML Designer. And this is really going to be interesting for some of you who don't really want to code. You just want to be using a drag and drop to configure your pipeline and then be able to create a machine learning model and then also host it for people to consume. So the prerequisite is that you would have completed lab 1A and lab 1B before joining us, or you would have understood what we did in lab 1A and B before you can join us here. So again, once you go to the compute page here on this other platform, ensure that your notes are there. And then ensure, again, we are going to make some changes to ensure that the minimum number of nodes we have is changed to 2. So we are going to edit our compute cluster and change minimum number of nodes to 2. So this will only mean that you would have less amount of time to wait for your cluster to start. Okay? So every time 2 clusters are working and running. So this is what exactly we're referring to. We're going to edit this and set minimum number of nodes to 2. Sorry, it's loading. Okay. Yeah, so let's set our nodes. Yeah. So we're going to set this to 2. So let's wait while that's being done. It's
The
trying to
maximum is
access.
also.
Yeah.
Okay.
We're not required to change this. So both of them are going to be 2. Yeah. So do you understand why we changed that to 2? Are you with me?
Yes.
Do you understand why we set it to 2?
You
For
said
up
so the waiting time reduces or something.
You said what?
I said you said something about time.
Yeah.
Like we don't have
Yeah.
to wait as long.
Yeah. When you want to start it, you want to run your compute. So you need to understand that you are working with VMs here. So you're working with VMs here. And if it's set to 0, it takes a longer time. Your minimum, it will take a longer time to start. But when you set it to 2, your minimum number of nodes, if you set it to 2, it will start quickly because it keeps on running. Minimum says, I don't want anyone to be running at all. So which amount of it I want to be running per time. If I say 0, it simply means none should run, especially when it's left idle. Okay, so while we are trying to resize it, it's taking time. I did an introduction to all of this yesterday. So these are basically where you do your coding and the likes, or you do your drag and drop. So this is where we are coming. Go to design, and you create a new pipeline. Remember, everything you're working on is a pipeline, and there are samples here. You could use this sample binary classification, wide and deep-based recommendation system, maybe for a restaurant or for a website you are building, or just like YouTube that recommends a video for you based on the one you've watched before. So if you want to build such system on, let's say for instance, a product we are building right now, or we want to start working on internally, where people come to buy services. So we want to make recommendations to them based on services they've bought or purchased from us. So you can use these recommender systems to build that. And then also showing you want to predict prices of things. Of course, you know, regression is a great a model, a great algorithm to use to when you are dealing with predictions. Right. So we're going to click on creating a new pipeline. And there's a name we are going to give it. We are going to change this name from what it is here and give it a default name that we are supposed to give it, Visual Diabetes Training. Okay. Right. Okay, so this is what we've done. And then we also need to select the compute, which is this. This is the compute cluster. Remember, we already resized it to 2, which is why it is showing like this, okay? So it is set, the cluster is set. How do I explain this now? You are trying to work. You are also trying to set the environment in which everything you are doing here is going to run. So how do you do that? You need to set up a cluster just like you were doing here. We are trying to, this kernel here is actually running on something, on the VM or the compute instance you set up. So that was what was happening here. So everything you installed on the compute instance is actually coming here. it's actually coming to this environment so that any code you run, that's how it's able to give you all this information about the workspace, information about the compute you set up, the data stores, and the data sets that are available. So that's how everything came to be. Okay, so the same thing you are doing here, by bringing this, you have all other information with it. So the next things you'll be looking at, you see the diabetes data set is already here. So the interesting thing about this is the drag and drop feature. Like you can just drag it here. Yeah, to make it resize. So this is exactly what you guys saw Eva using in the tutorial. How many of you have seen that tutorial? Or you already know exactly what I'm talking about? How many of you? Are you guys with me?
AI 42, right?
Yes, AI 42. Mm-hmm. Okay. Your response rate is actually low. I don't know what's happening. Okay, so but I do hope you're able to follow me since. Are we together?
Yes, sir.
Yes, this is everything. So you can also view everything about your data and how it looks here by using the visualize. Once you visualize, it will show you how the data looks here. So it does a profiling of the data. So this is how it looks. So it is more like predicting diabetes among different age range. You can create this model and also test it on yourself to know or predict it for yourself, just so you have all this other information. So this is your label, yeah?
How did you add the data set? I missed it.
This is the data set here. So there are different controls here. There are different controls here. There are even sample data sets here. Different data sets that you have here. Flight delays, German credit card, movie ratings, weather data set, Wikipedia, animal images, restaurant ratings, and customer data. Different sample data you have here. But remember, we added one into this our workspace. So by default, it will show you the one that we added to our workspace here, which is this. So all you need to do is to just drag it. It's as simple as that. So you just drag it to this environment, and that's all. Is it clear? Guys, is it clear?
Wait, so
Yes, sir.
the data set. Yeah.
All right. Okay, so the next thing we want to look at is how to do the transformation of the data. So of course, when you get your data, you first of all need to understand the data, look for missing values. You have to check for outliers. Then you explore it. When you're doing this, we call that data wrangling. You wrang the data, W-R-A-N-G. You wrang the data, clean it up, make it look exactly as you want, because you already know what you want to do with the data. You know what columns matter to what you're trying to predict, and then you remove the noises in your data, and then we can use different methods to do that. So here we are going to expand, go to the data transformation section, and then we're going to drag the normalized data to the normalized data control to the environment, and then connect it with that data set. Okay, so it's going to serve as the input. So this is exactly what I'm saying. You come to data transformation here, and then you look for the control to normalize data. You can search here. Let's just do this. So you normalize. So you're going to drag from here to here. You've connected the data set to this guy. So the different settings you have to do, you have to specify the columns that you want to transform. So you're going to click on edit column and set it on all of them. So here, now you are using is this score to do your scaling, just to remove disparity in your data to ensure that everything is kind of uniform. I do hope that is clear for some of us who are not familiar with these terminologies we are using here. Hello, guys.
Sorry. What did you say exactly? Yeah, in my network is lagging.
So I said we are going to normalize the data. First, let me even ask you, what is normalization?
Okay. Normalization is when, sometimes some data, some aspects of data have different ranges. Like height could be from 0 to 6 inches, whereas height of building could be from 0 to 600 inches. So normalization brings them to the same level.
Okay.
So that the visualization of the graph, it doesn't look conspicuous, like it's easily understood. Maybe like convert them to percentage instead of their original values.
Okay. So yeah, so that is exactly what normalization is. There are different mathematical methods you could use. This min max or the logistic or the log normal or the tan that you can use to normalize, to scale everything to be on the same scale or on a uniform scale. And just like she said, to bring everything close to each other. Right? And she gave a very good example, maybe using a percentage instead of the actual number. So a percentage of this, let's say of 100, and you bring everything down to a good scale. All right, so we'd have to edit columns and specify the columns that it should normalize, and it's almost all the column. So we are going to normalize all these columns. Plasma glucose, diastolic blood pressure, tricep thickness, serum insulin, BMI, diabetes, pedigree. So all this, we are going to add them. So based on column name, we're going to add plasma, which one again? Diastolic pressure, tricep thickness, serum insulin, the BMI, diabetes pedigree. So this is 1, 2, 3, 4, 5, 6. Everything. Yep, this is the 6 of them. So this is just it. It's basically to avoid columns with large values, so that your model doesn't look skewed, the SKEW, towards one direction, because you have so many of these. Let's say you have so many people in this your data set that are 40 years old, and you have few people who are maybe 26, and you want to distribute your data to look at your data distribution, you will see that everything is skewed towards 40, because that's the large. But what normalization does is that it evens everything. It makes everything look on a uniform or look uniform. Okay. So now that we've done normalization, selected columns that we want to normalize, we are going to do splitting. So basically why you want to split is because you want to have data, a portion of your data you want to use for training, and another portion of your data you want to use to validate or to test. Okay. So now we are going to add the split data model, and then we are going to connect it to the normalized data. And then we are going to do these specifications on the split. So we are going to split rows, and then what fraction? 0.7. So we are taking about 70% of it for training, and then 30% for testing. Then the random seed will be 1 to 23. Then we are going to set this stratified split to false. Okay, so here we have come across, no, we haven't. You might also want to learn about smooth. Smooth is just a mechanism of generating instances in your data based on existing instances, so as to level up or create more examples in your data. So you might have to learn how to use smooth, just in case you have limited data. So we are going to connect sorry, to the left, sorry. Okay, so we are going to specify this. We are splitting rows, and I want to do 0.7. This we are going to set to 123. This is false. Okay. Right, so everything is cool. Now that we've done that, I hope you guys understand what we've been doing so far. Any questions?
Sir. So I wanted to ask something.
Yes, sir.
Okay.
When we're normalizing the data and selecting columns, I don't know whether you explained it. There were two ways to select. You either select with rules or by name? I wanted to ask what the difference was.
To select, under where was that? When we're normalizing?
Yes, sir.
Okay. So when you're saying with rows, it's probably going to be based on a condition that you're going to set.
Okay.
Yeah, so maybe you want to normalize only among age groups. If the age is between this and this, maybe 40 and 32, normalize, because you'd have looked at your data and see how the skew of your distribution is going to look like. So based on what is going to look like, you can actually specify you can specify whether you want to set up a role that it is going to use to do the normalization.
Okay.
So for those of you who did normalization back in school, you did the third level, the second level, first level normalization. So they're really important things, concepts you have to learn. I know some of you did that with regards to database design and all that. So it's also important here that you know what normalization is. Any other question?
So I have a question.
Okay.
Okay, while you were splitting data, while you were using the split data module, there's random seed 1, 2, 3, and stratified split false. What do they mean?
So, random seed is basically specifying how it is going to generate, because you are splitting, dividing the number of seeds of rows you have. So it's randomly going to do a selection, a random selection amongst your rows. So setting it to 123 is like giving it the rate at which it's going to be doing the seeding, and that it's going to give you this exact number of it. So the rate here, and then this. So stratified, I'm not really clear what this is about. But in my head, I'm thinking should be maybe selecting based on what looks alike, or what. So maybe I think we can search on this. Let's get it clear.
So I don't still understand what you mean by, like, how is 1, 2, 3 a rate for the random seed? I don't understand.
Sorry?
You said random seed is like rate at which it randomly splits the data.
Yeah, I think exactly. I got
so
this. Yeah, you said?
I was saying that how does 1, 2, 3 does them do the splitting? How does it do the splitting? Does it take the first
sir.
3, drop 1?
Okay, I should come in here, please, sir.
Okay, who's that?
Okay.
Daniel, right?
It's not Daniel.
Okay, you can talk. We can hear
Joshua.
You. Okay, Joshua.
Okay, that random split, what it means is that it helps for you to get the exact data set. Like, for instance, now, if I'm working on a data set and I use this code, this 1, 2, 3, and I give you the data set to work on, you also make use of this code, this 1, 2. I mean, it's not necessarily a code, sir. It's just like a particular numbers or number that we just choose. So if you make use of this random seed at your end, you will likely get the same figure or the same model we have. It's just like for us to get exact let me say exact answer, or exact like similar answers. That's what it means. Hello? Are you there?
Sorry.
What happened? It's my network. Okay.
Did he explain to you well?
Yes, I understand now.
Okay. Sorry, I didn't hear you.
I thought you were
Sir?
getting for stratified online.
Yeah, so I think with my previous explanation, it was very clear, or I got it well, just that I wasn't sure. And so it's basically trying to select, do your splitting based on similarities that exist within the data. So, like I said, it tries to look at the attributes of your data and how it classifies them, and then tries to group them based on similarities they have, maybe it's same age or same height. So these are the different things it looks like. So we said, no, we don't want it to look at similarities between the data and group them to form this 70% we need. We just want it to generate randomly. Remember too, because that is going to affect your model. Is that clear?
Yes, sir.
All right. Okay. Any other question? Any other question, guys? So this is exactly what we are trying to.
Yes, sir.
And then let's see how far we can get here. Right?
Sir?
Okay, you have a question?
Yes, please. Can you take it back? I want to ask, is it no that frame, like that structure, like the data sets, the normalization, the what's it called? The split, Abby? Yeah.
Okay.
The split. So I want to ask, is this a prototype, like this? That means if, for instance, you want to work on this visual machine learning now, is this the step, the prototype one, how to pass through? Like you bring out the data set, place it there, you normalize,
these are the steps.
split it.
Yeah.
Okay, these are the steps. Okay,
Yeah.
all right. Because
So first thing, like I
saying
said,
something that okay.
First thing, like I said, is once you bring your data, you personally have to visualize, take a look at your data and see how it's the distribution in your data. If it is skewed towards a place, if it is not skewed, maybe you have missing value. If you have missing value and you want to remove missing values, remember I said the next thing you want to do when you bring your data is that you want to clean it or do transformation. So in cleaning, we are trying to remove outliers, remove null values. So when you look at this, see, you're looking at different transformation models you could use. Clean missing data. So you can specify how you want to handle missing values in your data set. So depending on the need you have, the first thing is that you must bring your data in, and then you can use any of the data transformation model. Maybe a colon is missing, a row is missing, or you want to apply mathematical operation or a SQL transformation, or you want to remove missing values, or you want to remove outliers, you want to also do anything, or you've done, once you finish cleaning, you want to save it back to a CSV or convert it to another data set, maybe a cleaned data set, whichever one you want to do, you can do them here. Or maybe you have two data sets that you want to join, you can use the join. Now we used normalize. You can do partition and sample. You can remove duplicate rows. So it depends on what you want to do here. In fact, if not that we're following this thing, I would have even removed duplicate rows before I even do normalization. Or maybe we are just following exactly what we have. Okay, so there are different things you can do here. It's not cast in stone. Okay. Is it clear?
Yes, sir.
Is it clear, guys?
Yes, sir.
Okay. All right.
Yes, sir. Yes, sir.
All right. Okay, so let's have more fun. So the next thing we want to do is to bring the training model to this, to add the training model. So there's another pane, another subsection for this, which is called model training. So we are going to have two splits now. On this aspect, here we have the 70%, here we have 30%. This 70%, because we split this data now, this 70% is going to be used for training, and this other one is going to be used to test the result of our training. So we do a scoring. We're going to score our training. And then later on, we evaluate our model, right? Okay, so the first thing we want to do, we are going to bring in the train model and connect it to the left of the split data. Right. Then we are going to bring another, maybe a machine learning model to use it to do the training. So this is the training model. Then we drag this here, train model, we attach it to the right. The machine learning model is going to connect to this, to the left here. So which of them we are going to use? We are going to use logistic regression. Does anyone want to tell us why we want to do it with logistic regression? And in this case, it's a two-class logistic regression. Anyone? Or let's even ask
Why we want to use logistic regression?
Yeah.
I think we want to use regression because what the results we are probably looking for is not a classification, it's a result that would give us values as our answer and not classes of results.
Okay. That wasn't clear.
Okay.
Okay.
To me. Okay. No, true. After you. I will speak after you.
Yeah. You speak after who?
Okay. So I was saying that we're using regression, logistic regression, because it is a regression case and not a classification one. That we want a result that will give us values and not classified into different.
Okay. So in this case, I think Joshua wanted to try.
Yes, the reason why we are using the logistic is because we are trying to find the relationship. That means the cost of we're trying to find the cause of the diabetes, like which of these parameters has effect on the diabetes.
Okay.
And since they are all numerical numbers, like the data sets are integers, so that's why we're making use of the logistic. Like what Olamide said, is not a classification issues, and that's why.
Joshua, please,
Mohammed, you are
there's
here.
a noise at your background.
I'm sorry.
All right. Okay. So thank you so much, guys. You guys tried to explain it. So just like Olamide said, we want a figure or a number, maybe not number. We want a value, yeah, a value to be returned, and we're also considering different hierarchies in our data. And we're working with numbers here. We're also looking at getting either a result of either a 1 for patients who have diabetes or 0 for a patient who doesn't have diabetes. So how are we going to do that? We want to have a column that we would be predicting. A column we would be predicting. So even your test data already has a value on that column. So we want to see how correct we would be able to predict the value that is already there in the test data. And you'll continue to do this. It's not just once. You don't try your model once and expect to get it correct. Once you've done it, you need to continue to tweak it and tune it until it gives you the best outcome that you want. Usually, I like working towards 90 something percent, and then as much as possible, it is giving you a very close answer to exactly what you're looking for. So you are also careful about the false negatives and true negatives, false positives, and true positives. So you are watching out for those scenarios, and then you be. So this is why this is really interesting. Sometimes you ask the computer, "Don't you have eyes? Can't you see that this is not this?" Or you are predicting if a man wears cap, and your system is predicting for you that he's not wearing cap. Meanwhile, he's wearing cap, just that the color of the cap has changed. The color of the cap you used to train it is green, and the man is wearing yellow cap in your test, and you're saying he's not wearing cap. So how do you want to check or correct that? So you just have to add new data to your data, ensure that your data set is very rich enough for you to be able to know, oh, I've seen this before, let's predict it and all that. So it's one of the reasons for me this field is interesting. We are trying to teach a computer to be smart. A computer we once thought is smart. Okay, so let's go onto this under machine learning algorithms, look at the one we want to use under our classification. So we want to use a two-class logistic regression because the outcome we are predicting is either a 0 or a 1, whether you have diabetes or not. That's just what we want to look at. So, sorry, man. So we're going to connect this guy to this. So far, what we've done is that we brought in our data, we normalize the data to reduce disparity between our data. Then we split it into training. This is the training, 70%. This 0.7 here is 70%. One here is 100%. So 0.7 is 70%, meaning the remaining 0.3 we are going to use to test. So we've connected. The model we are using is a two-class logistic regression. That's the machine learning algorithm we are going to use to do this. Okay. So the next thing is that we want to test what we've done. So we are going to add a score model to the canvas and then connect the split and the train model to it. Okay, so this is going to look like this. Sorry, expand. I hope this is interesting, guys. Please let me know.
Yeah, it's very interesting.
Okay.
But we need subscription.
Yeah. Okay, so you come under the model scoring and evaluation. And you're going to bring out the score module and bring it. Sorry, this is my own canvas. I need to do something. So we're going to do this basically and connect this to. So here, you're connecting the training results here. And you're connecting the remaining test to this part of it. Okay, so your data set, this is another data set. You divided your data set into two using this model for training and for testing. Okay, so far, where is this guy? Oh, sorry. Remember, we need to specify our label. So who wants to tell us what a label is? Very simple. Aside Olamide now and Joshua. Aside Olamide and Joshua, who wants to tell us what that is?
So what did you say, sir?
What is a label? A label. Your machine learning, let's say you are doing a model, you are working on a model. What is the label of your model?
So I would like to try, sir.
Okay.
Labels are like how should I, what's the word? Labels are like features. After you're done training the model and then you want to assign labels, like features. For instance, what we are currently looking for, we are currently looking at the diabetes data, right? I want to figure out which one, who has diabetes or who doesn't have diabetes, basically. So like the label is like kind of like a feature that you assign that to some particular values, and then you're going to use it to test the model to see whether you get results. I'm not sure if I'm right.
Okay. Yeah, thanks for trying. Yeah, thanks for trying. That's a good try. Let's also get other opinions from here. Who else wants to try?
So, to my own understanding, I think label is just the output classes. The output class, as in the group, maybe after everything, the class that it belongs to. I think that's just the label. That's the label.
Okay, another awesome try. Awesome try. Okay, Olamilekon, want to try?
Hello.
Yeah, we can hear you.
Can you hear me?
Yes, I can. I can hear you.
Hello.
Olamilekon, we can hear you. Ooh, it's really, I am not sure he can hear me, but I can hear him. He's repeating. Okay, you can speak. Just speak. We can hear you. Yeah. Okay, let's move on, guys. Let's move on, guys. So your label is actually what the colon you are trying to predict is just that's why I say it's simple, guys. Is the colon in your data that you are trying to predict. Which colon? So let's look at let's visualize our data again. Which colon are you trying to predict? We are trying to predict if somebody is diabetic or not. And this is the colon, diabetic. And it has values here in the data we brought. So what we are trying to do is that our test data too would already have this colon. Our test data will have this colon. We want to see if we'll be able to get it too after doing our training. So we are going to predict whether we'll get this 0, we'll get this 0, we'll get this 1, we'll get this 0, we'll get this 1, something like that. So this is our label, diabetic. Right, so we need to specify the label here. We're going to select colon name. Colon that is going to be our label. And then save. And that's all. Okay, now that we are done, we need more explanation. Yeah, I can hear you.
Yes, I want to confirm something.
All right.
Okay, the model we are doing right now is a classification model that is supposed to give us 0 or 1. But we're using the thing we are trying to do is classification problem. But we're using logistic regression. So that means it's possible to get something like 9.5 as a result, right? And then since it's closer to 1,
you can't get 9. You can't get 9.
So you can get 0 or 1.
Yeah, you can only get 0 or 1.
Oh, okay. That is C class. Okay.
Don't worry, you see what we are saying once we are done, okay? All right, so the next one is then we want to evaluate it. So we want to evaluate, and how do we evaluate? What do you mean by evaluation? What do you mean by evaluation? Guys?
Evaluation.
Yeah.
Yeah?
Yeah.
Someone's hand is up.
So what's evaluation?
Evaluation is not accuracy. And the other types of evaluation.
Okay. Yeah. So
I think
Like
yeah,
using
yeah.
the false negative and false positive in calculating.
evaluation simply means accuracy and your precision. So
Okay.
know how accurate it is.
Yeah. Awesome, guys. Wonderful try. Yeah, you got it right. You're considering um, your accuracy, your recall precision. To what extent can your model recall, and how precise it is in recalling? And then you're also trying to know, using that to know your false positives, or based on your false positives to calculate the precisions and all that, false positive, false negatives, uh, true positives, true negatives, and all that to calculate or evaluate how accurate your model is. So what we are going to do is that we are going to drag in the evaluation model, and then we are going to connect it to the score model, then see how it looks like. So we drag this. This is the evaluation model. We didn't drop this. Okay, it didn't drop somewhere. Okay, didn't. All right, so I'm going to drag it again. I'm going to drag it here. The evaluation here, can use evaluation to compare two models. Let's say, for instance, I created this model, this one here. I was referring to removal of duplicate records. Let's say we created another model that we removed duplicates, we removed outliers and all that. We did different transformation on it, whether the result will be different. So this is how you compare one model to another model. Okay, so this is for model 1, this is for model 2. Then you'll be able to compare their results or any other thing. This is going to connect to output. Don't worry, you see how this looks like. You see output here, and then you see, oh no, I think it will remove this and put output here, and then to this place, to where now? I think either here. It's going to remove it and also remove split and then add input so that you can send input to it. Just this, that happens when you're trying to convert it to an endpoint, but we are not talking about that now. We are talking about the training itself. So let's just focus on what we're doing. All right. So the next thing remaining is to connect or to run the training pipeline. So first of all, let's verify that we have everything working fine. And then you can put descriptions, okay? Just that we didn't do so much of that here, but it's good that you do or you put description in the work you're doing. By description, I mean this. Let's zoom in. Putting comments here. Saying 70% for training and 30% for testing. So it all appears here. This is how you basically add comments to it, okay? Any one of them has comments, you just scroll down, put in your comment here. So class logistic regression. All right, okay. So next is to submit. I did something like this when I was taking us on a data factory, on the data engineering aspect of all these things. And I show us how you have to publish before you can actually run your pipeline. Publish any change you've made. Just in case you made a little change, you need to publish it first before you can actually do any test or run it. Okay, so here we go. So we just click on submit. Anything? We don't have any experiment. So let's create new experiment and give it a name. What name should we give it? Sorry. Yep. So visual training is what we call it. And then it might actually take a while to do that. But let's just continue. So the compute target is our skills lab cluster. Then with these names, yep, so pipeline 1. I already renamed it. It's trying to run it and all that. Okay, so what's left? But you would see that it will be checking anyone it has run. To try to run each of them and tick it and do that until everything is set, okay? Or you see a mark that shows you that it is done with that. So while that is on, any question, guys?
Yes, I have a question.
Okay, any question?
Yes, and my question is, I think I've asked it. I think I've asked it before now. But
Okay.
let me get something from you. Okay, now the question I want to ask is this: from the look of things here, what we just did, it looks so easy and simple. We just drag and drop and input some figures and all that. Now, can we use the same way that the traditional method we normally use? We use our Python with the Jupyter notebook. Can we, like, if we choose not to make use of that normal traditional method and we choose to do this one, like use this as well, are we going to arrive at the same endpoint?
Yeah, you are going to.
Okay.
You're going to. So
it is
the beautiful thing,
that,
the beautiful thing is if you look at this too, look at this. It's run this. It's trying to run this too, guys. And once it's done, you would still running. Look at this. You can see Python language, R language, different things. You want to create a Python model, you can drag it here and you will write your Python script.
Code. Okay. Okay.
You understand? So different
Okay.
things, you want to do computer vision, image transformation, blah, 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 whatever you want to do, you can bring them here and then also connect it. Remember, we are saying the first one at the top will serve as input to the next. So
Yes.
if you are doing, let's say you have a data set of images, you can bring that into this place and do transformation on image, blah, 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 whatever you want to do. And also, maybe you are not satisfied with it. You want to use Python to finish the rest, you can also bring Python script to connect your transformation to it. So whatever you want to do, this environment can also help you do it. But if you are very comfortable with the traditional way and you just want to do your thing without being disturbed so much, what you can do is to use the Jupyter notebook. Don't worry, we are still going to look at all those in the next sessions.
All right, sir.
We've not even gone far. We are just on what's this? Lab 2A. Lab 2A. You've not even gone to lab 2B. You are going to where now? You're going to lab 10.
10. Wow.
So you've not even learned anything. You've not even learned anything. So this, guys, is the real deal. This is the real deal. And I really hope you guys can be open-minded because you are going to learn a lot.
And
But
that's
is
A
it
and
possible?
B, A and B.
What?
Yeah, but is it possible?
I said
Is
it's
it
not
possible
just
that
10, it's
for
20.
one?
Two of you are talking at the same time. I can't even get any of you.
And that's why I allowed her to talk first, then I will talk.
Okay, so Olamide, let's hear you.
Oh, no.
He's not saying anything.
I was saying that the 10 are A and B. That's what I was just saying.
Oh,
At the
okay.
lab.
Oh,
That there are 20 10.
Yeah, they are A and B.
okay.
Be ready for the A
Okay,
and B.
okay, sir. Is it possible for one to know this Azure machine learning and not know the normal traditional method? Is it possible?
No, it's not possible.
Assuming, sir, I have a question.
Because if you are doing this, it will also help you know the traditional method too.
Okay. Okay.
Yeah, so this is what this training is about. It's
All right, sir.
preparing you for a work environment.
Sorry,
All right, sir. Thank you,
I
sir.
want to be sure of something.
All right.
Traditional method, they deal with past data, right?
Sorry, I didn't get that.
Traditional method, they deal with past data.
With past data.
No, not to
No,
the past.
it's not like a rule. It's not a rule. What your data set can be anything. It can be new data, it can be old data, it can be combination of both, it can be different things. So whether traditional or modern, it's your data set that determines what your model looks like. But for a rich model, we just advise that you have enough data from past, recent, all category, and all that. Does that answer your question?
Sir, thank you very much, sir.
All right. So Oh, Microsoft has another portal. Ibiza portal. So guys, I might have to round up with us as soon as possible.
So we didn't get the recording for yesterday. I can't view it.
Yeah, so I'm waiting for Microsoft to send me. I've not seen it too.
Okay.
So let's see the foundation model. So these are the outputs. So let's see the score. So it's done. Let's view our model. This guy is failing. I don't know why. So hopefully it doesn't fail. Wow. Wondering why Microsoft is not allowing us to view evaluation results. So it's kind of encrypting the results. So we are supposed to go somewhere. We are supposed to go somewhere and check the results. For that place, I can't access it. I'm wondering why it is giving us error. I'm supposed to view this. What's this, guys? Okay, let's see. Yep, this is it. Okay. So look at what the normalization did. Puts everything in this format, then tries to predict it. So this is the score, and this is the label, the score labels, and this is the actual thing that we have. So look at how close. This is the test data. This is the original data, and this is what it tries to predict. So it got this, it didn't get, it got this, but it didn't get this one. So here it predicted one, Meanwhile, the person is not diabetic. Then it also missed one here, it missed one here, missed this,
Miss the other one.
missed this, got all this correct. But you can see the degree to which it is accurate. That it has, this is like a false positive. Yeah, you have false positive. Then here, yeah, and sorry, here you have a false, yeah, a false positive, looking for a case where it has a false negative. Yeah. Sorry, there's a false negative. So you can look at, see what this model tried to predict, and then we had about 10,000 rows. We used 7,000 rows to, and now we are testing with the remaining 3,000 rows. So let's see our evaluation. See. This one, yeah. Just view the output of this one. It's showing us what we want to see now. So yep, so look at this. The rate of positives and the number of true positives is compared to false positive rates. Look at the curve. So you have true positive rate as compared to false positive rate. You have more of true positives compared to this. Then the precision. Look at, there is actually it actually did well. Normally it's supposed to come like this. Okay, so it's, the curve is just telling us that the model did its best to give us a good outcome. Then the prediction versus the actual, it actually got this guy well, but it actually got some wrong. Got this well, got some wrong. So look at how many.
Sir, can you?
Yes, how many of these were wrong? Yeah, this is hard.
Okay, like
this is actually a poor performance, if you ask me. Yeah, you have a question.
no. I want you to explain that chart for me. Yeah, this
Did
answer.
this?
Yeah.
Yeah,
Yes.
I just did. Did you get it now?
No.
Like I said, these are the correct ones. This and this are the correct one that it got.
Okay.
And it failed
Okay.
this. The actual here is 0,
Yeah.
but it predicted 1.
How many times? 245 times.
45. And the actual here is 1, and it predicted 0, 397 times. These are the only two it got correct. Out of 3,000, it got this plus this correctly and failed this. This is almost 600 plus.
Yeah, if you failed, yeah, it paid almost 600 plus. Yeah.
Yeah. So what do you guys think about this model?
It's an average, like average performance. So
I think this is above average.
All right. So I advise you guys to go through on your own, try to practice, learn more of this. I'm going to shut my system down. So thank you so much, guys. Let me set this guy back to 0. Yeah. All right, thank you so much, guys. Thank you for joining me on this session. It's been a very
Thank you so much, sir. I
I
really
hope
enjoyed
you
myself.
learned. All right.
Yeah.
Thank you, guys. If possible, if it's going to be possible to have another session tomorrow, I'll let you guys know so that we
All
can
right, sir.
finish this. Okay.
But
Okay.
Yeah. Yep.
All right, sir.
So I think it's selfie. I like to take selfie with you guys.
actually, oh my, you see my face.
Yep. So today I'm well dressed.
But
All
I'm
right.
not well dressed. So. I'm coming.
Oh, picture time. Picture time. I can't see everyone. What's happening? What's the date?
I'm coming.
No. Okay, I guess the others are hiding their faces today. Is it because I hid mine? Where is the Telelola, Olamide, Aziz, Joseph?
Currently not available.
Aziz.
Olamide, come.
Where's Aziz? Aziz is not here.
Aziz is here.
Okay.
I can see all of you here. All right.
All right.
One more. Is Olamide on? Okay, she blurred her background. Don't want us to see your children. Okay. So let's
Done.
let's move to our gallery. Together
Done.
mode. No, we're not done. Trying to switch to together mode. All right. Where are the rest? Let's change scenario. Yeah. Which one is this? Let's see. And this is actually bad. I don't like this.
Let's use this one.
Which one?
The one or chair, that dark chair. Near that white one. I think it's fine, yeah.
This one.
Yes.
Okay. Right. Look at Telelola's face hiding and Teleola. Sorry, let me not forget. Why are you hiding your face?
Thank you so much.
Okay.
Okay. All right.
Thank you so much, guys.
Done.
Thank you,
Yep,
sir.
we are done. Thank you.
Thank you, sir.
I had fun today. I hope you did too. And do enjoy the
Alright,
rest
sir.
of the day. All right. Thank you.
All right, sir. Thank you very much, sir.
Bye.